Okay, let's look at the last problem on worksheet 2. If you understand the last problem, I think you'll understand all the previous ones. You can do all those on your own. Um, so let's go over the overall idea here. So we have this bike A. This is where they are in miles, and this is the time, right, in hours. And we find in 1 hour they're in the same place. They're both 10 miles down the road. So they're in the same place at 1 hour. However, this bike starts off going more distance, like in the first quarter of an hour, first 15 minutes, it's all the way past 4 miles, and this one's only gotten to a little over 1 mile, right? So this bike starts off faster, this bike starts off slower, but at the end, bike B is going faster, and bike A slows down. So maybe this person, right, just like in any race, started off too fast and got tired, and the other person started off nice and easy and sped up, and they got to the same place at 10 miles, and then bike B looks like, assuming bike B kept going this way, bike B keeps getting ahead. Okay, so the point is, the whole point of this is that the velocity or the speed is the slope, right? So the whole idea is the speed is equal to the slope. And it's about drawing tangent lines, because we got to guess. I don't know what the slope is right there. There's no way to figure out exactly what the slope is right there. If you take 2 dots, then we know kind of what the slope is in the middle, right, an average. And even that's not quite right, because maybe the slope isn't changing evenly, and that's the whole point of like web assign 2, is trying to figure out the slope at a point by knowing 2 points, and then we want to take those 2 points as close together to get the exact speed at 1 point, which is kind of impossible, but you can do the best you can and guess, pretty well what the answer is. So that's kind of what we're getting at here. So we're trying to guess the speed from the slope. So the first one says calculate their speed as they start out as best you can, because you can't do it perfectly. So I'm going to draw what I think the slope is when they start out. So it looks like it's like this. So I'm going to try to draw a line as best I can. It obviously helps to have printed this out. I mean, I realize if you're just looking on the computer, you don't want to draw a line on the computer, but you can still kind of guess. And that's that one. And then the other bike is something like this, looks like. So maybe that's the tangent line right there when they start out. So let me go to a half hour. So I'm just going to guess there. So let's go to the first half hour just to make it easier. Okay. So the blue one slope. In half an hour, I'm going to say they would have gone 12 miles if they had kept it up. Okay, so the speed for bike A would have been distance divided by time, right? The distance they went was about 12 miles in half an hour. So I would have gotten about 24 miles per hour. Again, I'm guessing. Someone else might have gotten 20 or 27, but it's rough. And then this one went they went about 2 miles in half an hour, right? So their velocity or speed, I'm going to use velocity because I like V better. S for speed looks like seconds and stuff. So their velocity is distance divided by time. They went about, again, right about here, a little over 2, but I'm going to say 2. 2 miles in half an hour. 2 divided by a half is 4, so about 4 miles per hour. Okay, that's part A. Again, we're guessing here, like they say, best you can. Okay, that's part A. And again, if you guess something different, that's okay. Okay, part B, calculate their common speed, the time you guessed found in question 3C. So in 3C, you're supposed to say, when is the slope the same? When are their slopes the same? So somewhere around, let's see, here the slope looks like, to draw a tangent line right there, looks like it's about like that. At that same time here, looks like it's about like, yeah, that's pretty close. Again, there's no, I don't know what the right answer is. I don't even have their answer key. They say, look at the answer key. Yeah, I don't really even have that. But I would guess right about there, right? The slopes of those 2 lines are about the same. So I'd say in about half an hour, about 0.5 hours, half an hour, they're about the same. So if that's the case, and it's somewhere close to that, if you said a little bit before that or a little bit after, you might be right. I don't know. But let's say it's half an hour. What is the speed then? So I'm going to extend my tangent line here. as best I can. Let's just use this point here. So to find the slope, so the speed, so in 0.25 hours, this person went, bike B went from here, looks like about 3 maybe, about 3 to about 6. And again, I'm just estimating because it's not perfect anyway. So they went 3 miles. So their velocity or speed was distance divided by time. They went from 3 to 6, they went 3 miles in about 0.25 hours. 3 divided by 0.25 is like 3 times 4. So let's say about 12 miles per hour. So that's what I'm going to say their common speed was. At 0.5 hours, half an hour into the ride, they're both going the same speed. About 12 miles an hour. Again, about. They're slightly different answers, right? But I think that's pretty close. Okay, so then let's go down a little bit. Approximate their speeds at the end of 1 hour. So now we just do that again. The whole point is we're trying to get good at approximating tangent lines. What is the slope at an exact point? And they're trying to get you to see it's kind of impossible, so you do the best you can. All you can really do is 2 points and then measure carefully. At 1 point, you just do the best you can. Okay? So we want to know the speed at the end of 1 hour. So you do the exact same thing. We have 1 hour, they're right here. This one is going like this. I'm going to make the line longer. Well, it's approximately a straight line, what they have. Well, actually, their speeds are pretty much a straight line right there. So, bike B, let's do B first. B goes from 8 to 12. So we'll look at this here. So it goes from 8 to 12, so the velocity, again, distance divided by time. 8 to 12 is 4 miles. The time is from right here. Okay, we got to guesstimate here. Actually, it looks like that's about one of these blocks, right? So that looks like about 0.25 hours, because that time there looks like about that time there, which is 0.25 hours divided by 0.25. So I get about 8 miles per hour. Wait, 4 to 16 miles per hour. 4 divided by 0.25 is like 4 times 4. 16 miles per hour. 16 miles per hour, that's what I'm going to say bike B is. And then bike A is certainly a lot slower. I'm going to make it in blue. Bike A in time, what, about here to here? That's half an hour. So the velocity and 0.5 hours. In 0.5 hours, they go from about 8 to about maybe a little over 11, but not quite 8. So let's say about 3 miles. Yeah, roughly about 3 miles. So about 3 miles. So I'd say 3 divided by that is 6 miles per hour. Again, you might have gotten 8, but you know, close enough. Obviously, bike B is going much faster. Okay, we're almost done. So then, part D says, are their speeds increasing or decreasing through the journey? Obviously, bike A is decreasing, bike A is increasing, and we can just put those numbers on that we had here. They say, use the information collected to sketch the graphs on their right. So you do 2 graphs, bikes A and B, and you just kind of sketch how fast they're going. So they started off at what speeds did we get? And then at half an hour, what were they doing? That's where we thought they're the same, right? And then in 1 hour, what were they doing? Well, 1 hour, bike A was going 6. So bike A was going 6, which is about right here. And so A is going to be blue for me. And bike B was going 16, so there's 20, so 16 is right about there. Wow, they go all the way to 40. I never got going that fast. And then what did we get at 0? And you just graph the lines. Okay, that's the idea here. The whole point of this exercise is first to see that slope is speed, how fast you're changing your position, how fast you're changing where you are is your speed, that's what it means. And guesstimating the slope by drawing tangent lines, by guessing the slope of a curve at a certain point, kind of impossible, but you do the best you can. And later in calculus, we'll see an exact way to do that, but there's not an exact way to do it from a picture. If you have a formula for the curve, then there's an exact way, but not from a picture anyway. So, okay, that's it. Hopefully it's pretty easy to follow.